Welcome to LinuxCNC for the bare bones beginner. In this lesson I want to cover the basic functionality of LinuxCNC as you would use it in the simulated environment in bootable USB form, to try and give you a head start on using the software as well as the Linux Debian operating system that it comes packaged with. So to get started, LinuxCNC will run on any computer that's been produced in the last 10 years as long as it has a parallel port. So if you have, for example, a Gecko G540 and you want to move away from some of the other software that you would use with a Gecko G540, you can test drive the Linux environment by going to the linuxcnc.org website. Under the download section, download the Debian 10 Buster Preempt RT ISO, which includes the operating system, LinuxCNC's actual machine software, and the real-time kernel that's required to run LinuxCNC. This is helpful for anybody who is sketchy about making the jump to LinuxCNC because they're afraid that they're going to spend money on expensive hardware and they're not going to like the actual operating system or the user environments that are available. So if you're completely new to LinuxCNC and you just want to test drive the software, you can go to linuxcnc.org under the download section and download the Debian 10 Buster Preempt RT ISO image. Once you download that image, you can go to rufus.ie and download the Rufus utility for creating a bootable USB stick. Once you do that, you plug your USB stick into your computer, you go to your BIOS setting, you tell it to boot from USB, and the Linux environment will start up for you right away. And it'll look something like this. It might be slightly different because I'm using Debian 9 and not Debian 10, but the software is pretty much the same. I'm using Debian 10 on one of my other computers. So when you first boot into Linux, you're going to notice that the interface is very similar to a Windows environment. You have a desktop that has shortcuts on it. You have a taskbar that shows your date, your time. Clock is customizable. Right now, you can see in the corner here, I've got a screen capturing software running. I've got my network configuration. I've got my name. My name will allow me to shut down, log out. Under applications, applications is much like a Windows start menu. I have run program, terminal emulator for, think of it as Windows command prompt, file manager, web browser, and then under settings, settings are like Windows control panel, accessories, some available installed programs that are on the computer. Under CNC, I have all of my LinuxCNC documentation, the actual LinuxCNC program, the configuration wizards that come to set up either parallel port or Ethernet-based hardware connections. Under the development section, I've got Glade for creating graphic interfaces for LinuxCNC. I've got Genie, which is just a text editor for writing computer code. So you can see that under each section, I've got different things. Kazam is the program that I use to capture screen. OpenShot is a program that I use for editing videos. The Pulse Audio is the volume control for the actual computer. When I go into that, just to show you, I've got my playback for system sounds. I've got my recording, input, output devices, input devices, things like that. So very much like a Windows environment. If you're at all familiar with Windows environment, the learning curve is very minimal to get yourself up and going in the Linux environment. And most people these days are very familiar with Windows environment. The one thing that you're going to find yourself doing in Linux more than you would on a Windows-based PC is using the terminal emulator, or in Windows it would be the command prompt. You'll find yourself in the terminal emulator more often in Linux than you will in Windows. And the only reason for that is because sometimes you're going to have to register yourself as a superuser. And a superuser is simply a sudo command. So you type in the word sudo, and then from there you can open up different applications as a superuser in order to make system critical adjustments or changes to certain files. So if I go to sudo mousepad, it'll ask me for my password. I put in the password, and it'll open up the mousepad text editor, which is basically like Windows Notepad. And it'll say, you're using the root account, you may harm your system. So this allows you to go in to your critical system files and make changes there. There are times where you're going to have to go in and make subtle changes to certain files, like in the case of the network manager, to register a Mesa 7i76 on certain distributions of Linux. You have to go in and just change a commented out section of the network manager in order to use the wired connection within the network manager. It's not as hard as you think. So to get started, under Application, CNC, LinuxCNC, it's going to load up the configuration selector. And from here, under Sample Configurations, Sim, these are all my simulated working environments. The two that I'm going to cover are the Asus environment and the Gmocha Pi environment. If I select Asus under the drop-down menu, and then I select Asus as the first selection and hit OK, it'll ask me if I want to copy the configuration to my home folder so I can customize it. If you say yes, it'll load. If you cancel, it will not load. So just say yes, hit OK, and LinuxCNC will open up. Once it's open, under the File tab, I have Open for opening a new NC program, Recent Files to open any files that I may have recently used. If I have a program open, I can use Edit to open up the editor. I can reload the G-code. I can save the G-code as a different program name. Under Properties, it tells me the name of the current running program, the size of the program, how many lines of G-code are in the program, the total rapid distance in the program, the total feed distance in the program, the proposed runtime of the program, and then the X, Y, and Z boundaries that the program is going to run in. On my graphic simulation screen, it shows me measurements of, in this case, the length and width of the characters that it's going to engrave. It shows me, over here, it shows me the starting and ending depth of my program. So it gives you a little bit of information as to what your program is actually going to do. Under Edit Tool Table, it'll open up a little spreadsheet looking page that shows me all of the tools that I have in this simulated environment. It allows me to add tools. If I select here, I can delete tools. So let me delete this guy here, 99999. I'll delete that. If I wanted to add a tool, say add tool. I'll say tool number 5. And it's in pocket number 5. The pocket is more for an automatic tool changer. For single tool machines, it's not absolutely necessary to put it in the proper pocket position. In the case of a milling environment, the Z table is going to be the height of the tool. The diameter will be the diameter of the tool. And then the comment will just be what the tool is. And we can say it's a 1/2 inch end mill 4 flute. When we go save file, it registers that tool to our tool table. If we had the configuration set up to load the PLC, we can go to ladder editor and we can look at the PLC that's running in the background. This is an optional thing. You don't need to have PLC configured to use LinuxCNC, but it's there if you want to use it, and I do use it extensively. Under the machine tab, we have toggle emergency stop, and if you look over here, it'll show you the keystrokes that correlate to certain functionality within the user environment. So instead of going to machine toggle emergency stop, I can press the F1 key, or I could just click on this little red icon here, which is toggle emergency stop. If I do that, the tab next to it, or the little button next to it, is to toggle the machine power, or to actually activate all of the user controls within LinuxCNC. Next to that, I have the open G-code icon. I have the reopen current file icon. I have run. I have single step, pause, stop the program, block delete, which if there's a / in my program, it will skip over that if block delete is turned on. Optional stop, so if there's an M1 in my program, it will stop at the M1. If I deselect that, it'll skip over the M1, but when it's active, it will stop the program at that position. Here I have zoom in, zoom out for my graphic display. And then here I have different viewpoints available to me to look at my toolpath. This will toggle between dragging and rotating with the left mouse key. And then the little paintbrush will clear out any kind of movement in my simulation. When I'm jogging around with the keyboard, you'll see little yellow lines that will display in the graphic window. And to get rid of those, I would just use that little paintbrush to clear them away. So once we enable our machine, our manual control window becomes active. And in this case, I'm going to do a home all, which will simulate a homing routine to send the machine back to its original machine 0 position. These little indicators here tell me that the machine has been homed out and that it's ready to set up and run. If I press the paintbrush, if we look here, see the yellow lines. If I press the paintbrush, it will clear those away. When I move the machine around in jog mode, you'll see that it traces yellow lines. It also shows me my current machine position relative to my home position. If we had homing switches on our physical machine and we home the machine out, the machine coordinate numbers will always be relative to those home switch positions. Underneath the machine coordinate positions, we have our absolute positions for our first work offset, which in this case is G54. Underneath that, we have our tool length offset values. When we're running a program, this DTG is our distance to go. So every line that gets executed, there is a start point, an end point, and between there is the current position and the distance to go position. So as the distance to go counts down, that line gets closer and closer to the destination of that executed line. So under our manual control window, we have the available axes that we can move the machine around in, X, Y, and Z. We have the directions that the machine can move in, plus and minus direction in each of the available axes. So to show you that, if I go to my top view, and I zoom in on my icon, this little icon here is where the control thinks that the machine is located. The X direction, in this case, will be left and right. The Y-axis will be front to back. And if I rotate this up, our Z direction will be up and down. So if we're on a vertical machining center, if we look at this graph here, the head of the machine will be our Z, up and down. The table, left and right, will be our X. And the table in and out towards the column will be our Y. Next to our jog buttons here, we have this continuous drop-down menu, which has continuous, 1 inch increment, 0.1 inch increment, 1 millimeter, and 1/8,000th of an inch. These are just samples. You would typically set your machine up to have jog increments that are respective to the system units that you have set up in your software, be it inch or metric. This simulation environment is just showing you the different ways that you can set up your continuous jog increments. Underneath that, we have spindle command, clockwise, counterclockwise, and stop. When spindle's running, we can increase or decrease the spindle speed with the plus or minus keys. Underneath that, we have our feed override, rapid override, spindle override, and our jog speed. Our jog speed, if I increase this while I'm in manual mode under continuous, when I use the plus and minus button, you'll see that the machine moves a lot faster than it did when the jog speed was down at 17 or 12 in this case. So I'll clear out my tool tracing. I'll go back to my perspective view. Under the DRO tab, it just shows you a larger display of your machine position, work offset position, distance to go position, so on and so forth. Under the MDI tab, MDI allows me to perform certain commands in a single line. So if I want to move somewhere, I can say G0, G91, and we'll say X 1 inch. G0 being rapid traverse, or rapid traverse, as I say. G91 is incremental selection, so from our current position, move X over 1 inch. If I said G0, G90, X1, X would go 1 inch from our current machine home position. If we have a work offset active with values in our G54, the absolute position would be 1 inch from the absolute position of our G54 offset. But in this case, just to toggle things around, we could just say G91, Y1, X of 2, and Z of minus 3. And we'll see that the cursor moves in a diagonal direction. If I go back to my top view, you can see that it moved at this angle. If we command a G1, G91, X minus 2 with a feed rate of 25. You'll see that the machine traces a little maroon line here, 1 inch in the 2 inches in the negative direction. So again, MDI is useful for single line commands. So if you wanted to start up your spindle, you could say S100 M3 for clockwise direction, and it would start the spindle up at 100 RPM. If you wanted to stop the spindle, you could command M5 to stop the spindle. You do an S100 M4 to run in a counterclockwise direction if your machine is set up to do so. You can also test out can cycle functionality. So if you know your can cycles, you could say G83, G91, Z minus 1, R0, F25 with a Q value of 0.250. And you'll see that it'll do a little peck drill cycle for you. In the MDI window, on the bottom here, this active G code, this shows you your current modal status. So it shows us that we're in G80, which is a cancellation of can cycle, G17, which is a plane selection for X and Y plane, G40 means that there's no cutter radius compensation being turned on, G20 is inch system, G21 would be metric system, G91 is incremental movement, G94 is inches per minute feed, G54 is our current work offset, G49 cancels out our tool offsets, our tool length offsets, G99 is the return plane for our can cycle, G64 is constant velocity control, G97 is constant RPM, so on and so forth. If we go to the machine menu up here, if we have a program that's currently running, we can run the program with the R key, or we can select Run Program from here. or again, we can press the little play button here. When I press the play button, it puts the machine into auto mode, and it goes and it runs the program that's currently in the machine at the position that it has set for the work coordinate position. In this case, it's using machine home, but machine home is arbitrary depending on where the machine was when it was turned off and turned back on, because this simulation environment doesn't have actual home switches. When I stop a program, if I go back to run, it'll execute the program back from the beginning of the program. If I pause the program while it's running, I can then use the single step button, which is this little arrow key here, or I can use the letter T on my keyboard. And that will execute the program line by line. Every time I press the letter T, it'll execute a new line. If I take the machine out of pause, the program will resume. While it's running, I can override the commanded feed rate with the feed override slider here. And again, if there were M1s in the program, I could select the optional stop, and on any M1 within my program, it would pause the program and allow me to manually intervene, open the door if I have a door on my machine, or do something that would otherwise be dangerous while the machine is running. So I'm going to close out the Asus environment, and I'm going to load the Momentary environment. This is an environment that is meant to look more like an industrial controller, and it's meant to work with a touchscreen. So if I go down to my sample configurations, under Sim, Momentary, and I just select the first one, hit OK. Again, it'll ask me if I want to copy the configuration. I'll say yes. I'll hit OK. And now it's going to open LinuxCNC with an entirely different user interface. First thing I'm going to do is I will go full screen because my laptop resolution isn't the greatest. But you'll see that the user environment is completely different than what we saw in the Asus environment. We have our e-stop up here. We have our machine enable underneath it. And again, if we mouse over, you could see e-stop machine is F1. Turn the machine on is F2. Here we have our X, Y, and Z jog buttons. We also have a C-axis because this is a 4-axis machine simulation. Here we have the selections of our incremental jog positions like we did with that drop-down menu. This window here is our simulated graphic environment, which will show us the machine moving around as we not only manually jog the machine, but also run in programs. Here we have our zoom in, zoom out, show or hide the dimensions of the program, show or hide the toolpath of the current running program, and then we have the little brush that will clear the tracing of the little moving icon. Here we have our different perspective views, just like we did in the Asus GUI. Here we have our modal G and M functions. Here we have our rapid override, feed override, spindle override, spindle clockwise, spindle stop, spindle counterclockwise. If I home out my machine, I can then move the machine around with the axis jog buttons. In Gmocha Pi, I have to enable the keyboard keystrokes, which is under settings. The standard user password to get into the settings is 123. Under hardware, use keyboard shortcuts. And then to get out of it, go back to the setting icon. And now I can use my keyboard to move the machine around. X and Y are the directional keys on the keyboard, and Z is page up and page down. To clear out our jog plot, hit the brush, and it goes away. On the right-hand side, I've got our manual mode, which is our jog mode, which is the screen that we're in now. Under MDI, I have the MDI window. In my case, I have it set to having a keyboard pop up. Here we can test out our functionality like we did before. The button underneath MDI in this environment is the auto mode. On the bottom, we have load a new program, which will let us load a G-code file. We have reload, play, stop, pause, single step. Then here we have a run from current line. Here we have our block delete. And then this one here is just full screen simulation. To the far right of that, we have edit our program, which will open the program in a program editing window, so we can make changes to it. When we're done making changes to the program, we can use this icon to save it, and then hit the back key to go back to the simulation environment. So again, I don't want to make this into a full tutorial on what every G and M code will do and what every function in the environments will do. I just wanted to give a brief overview of the functionality of LinuxCNC, what it will do, what it can do. We're just touching the surface at this point. We've loaded the operating system from a USB stick. We've gone into our LinuxCNC environment. We've used two different user interfaces, which there are a multitude more, not only as standard, but available online for download. But this is just a quick introduction for anybody who wants to test drive LinuxCNC. They're a little bit leery if they're currently using a different software and they're thinking of making the jump. This is to show you that it's not super difficult to acclimate to the Linux environment. LinuxCNC is very much like your other software controllers that you would be using, your Mach 3s, your Mach 4s. There's a couple of different things that need to be done for configuration-wise. If you want to do something crazy custom, then you have to start watching my other videos, like and subscribe. And for anybody else who might be watching this, I'm going to be doing some machine retrofits at my old high school. So if any of the students are currently watching this, hopefully this gives you a little bit of incentive to download the software and just kind of play around with it, see how things respond, move it around, run the test sample program in the Asus GUI, and just kind of get a feel for the actual environment, because there's going to be a lot of back and forth between using the GUI environment to move the machine around, as well as the configuration environments that we're going to be getting into, such as the configuration wizards, the HAL files, which allow us to do crazy customizations and things like that, as well as the PLC environment that we're going to be getting into when we set up the tool setters, and if we wanted to build a machine with an ATC, an automatic tool changer. An example would be the Fidel machine that's in the machine shop. Eventually, I'd like to get into that machine, retrofit that, and we would have to write all of the componentry for the ATC to actually change tools out of that machine. So thank you for watching. Please be sure to like and subscribe if you haven't already. Please stay tuned for future videos. Thanks, and hope to see you soon.